4 choose 0. Because now, of the 4 passed through the tree, I want 0 of them to be right paths. And b to the 4th, how many b to the 4th terms? Well, that's going to be 1, otherwise known as 4 choose 4, because now, of my 4 passed through the tree, the question is how many ways are there to do it in which all 4 are right? So it just all makes sense. What is, okay, so let's do it. What is a plus b to the n? It is time to state the binomial theorem more generally. If I raise it to the n, what's the first term? Never mind the coefficient. What's it going to be? It's just going to be a to the n, and I'll be a little bit more annoying by writing a to the n, b to the 0. And what is the coefficient? Well, actually, should we just ask one quick, well, okay, I think we just get it. So, yeah, if I have a path, if I want to know what this is, then I'm going to the depth of a plus b to the n, right? So if I'm going all the way down to n rows of this tree, then how many ways are there to get a to the n, b to the 0 terms? Just one way, because of the n choices, how many of those choices are to go right? 0 of them. So this is n choose 0, which is 1, right? I think we talked about this last class. N choose 0 is if I have n people, how many ways are there to choose none of them? One way. It also just works out if you do the, right, n factorial over 0 factorial n minus 0 factorial. Okay, how about the next one? Now I have a to the n minus 1, b to the 1. What's the coefficient? N choose, yeah, but I'm trying to let the choices be the number of ways to go right, just to keep it consistent. So this would be n choose 1. So I'm on the nth row of the tree. When do I get an a to the n minus 1, b to the 1 term? Well, I get one of those when I go mostly lefts, but just one right. So of all the n passed through the tree, or all the n choices to make, one of them is a right answer. Okay, let's do one more. Now this is like a to the n minus 2b squared. How many of those am I going to have on the nth row? N choose 2, because of the n paths, 2 of them have to be. Okay, then let's throw in a little dot dot dot. Let's skip to the a squared b to the n minus 2. How many of those am I going to have? N choose n minus 2. Are you cool? Okay, and then a couple more, right? How many a to the 1, b to the n minus 1 terms will I have? N choose n minus 1. And finally, how many a to the 0, b to the n terms? Now, of all of my n choices, n of them must be right. Okay, cool? Also, because we are big boys and girls, we can write this out in sigma notation, so let's do that. Would someone like to take charge? Running out of time? Yeah, everyone do it. Go right now. Write in sigma notation. This is the binomial theorem.
Variable start here, it starts here, and then after here.
With grades, it's just like, yeah, like choose I times a to the n minus b to the I, yeah.
Okay, so the way we've written it out, what is the number that keeps changing? Well, a bunch of them, right? Like this,
you can't be
it's
in
like
this video.
this number, which keeps going up by 1. So I'm going to write this as the sum
I'm not a nice person.
from I equals 0, because I seem to be starting at 0 and I seem to be ending at n. And this is going to be a to the, well, b is going to be raised to that power, and a is going to be raised to n minus that power. And what's the coefficient? That is the binomial theorem. A plus B. It's really just a counting problem. A plus B to the n is going to be a bunch of terms. How many of each one? Well, this sort of analysis, I think, makes it clear that these. Why? Well, let's do this. Let's skip that. I think there's a little bit of an explanation left to be made, which is what Pascal's triangle has to do with things. I'll leave that to you. Let's do these two problems up there. That clock's fast. Do these two problems, and then we can go. And I'll see you next class. Do it.
It's like 7 choose 3 times 3 to the third times 2b to the 8th, right? Group them different.
So we go down to 11 levels, and I went right 7 times, so the answer is
2 times n choose I, right?
11 choose 7.
Why
That would be
3
like
times
3
3
times
times
n
2?
choose I.
3 to the third, right? Times 2b to the 8th. 2b to the 8th because it's b squared. Yeah, and then that's it. We're
333, 330, yeah?
Do you know?
Okay, but then this other problem's a little bit harder.
You just gotta think.
Because when do I get an A? You gotta think of this as 3A is like the first thing, and 2B squared is the second thing. When do I get an A cubed B to the 8th term? Anyway.
When you have 3A.
Yeah, when 3A has been raised to the 3rd power, and 2B squared has been raised to the 4th power. How many times does that happen? 7. Yeah, I'm gonna, just for consistency purposes, I'm gonna write it as 7 choose 4. Wait, hold on a second. So the answer is 7 choose 4 times 27 times 16.